Hello and welcome to the UC Davis Energy Exchange webinar series. Today's webinar topic is how on-site non-potable water reuse systems can secure California's water future, barriers, solutions, and the business case. Our speakers for today are Amanda Rupiper, PhD candidate at the UC Davis Center for Water Energy Efficiency, and Amelia Luna, project manager and engineer for Sherwood Design Engineers. My name is Paul Fortunato, the creative specialist for the Energy and Efficiency Institute, and your host of today's webinar. The research presented today would not be possible without the generous contributions from our sponsor, the California Energy Commission. Thank you for supporting our energy efficiency research. Now, just a little housekeeping before we get started. Everyone who has joined the webinar is currently muted and is in listen-only mode. If you have any questions during the presentation, please type them into the question box in your control panel. I'll bring them up during the presentation, and we'll also have 15 minutes for questions at the end. I'll also provide a contact slide at the end of this webinar so that you may quickly get in touch with us. This webinar is being recorded and a copy will be sent to each of you. These webinars are a service provided by the collaborative efforts of the Energy and Efficiency Institute, Western Cooling Efficiency Center, California Lighting Technology Center, and the Center for Water Energy Efficiency. These webinars would not be possible without the continued support of all of our affiliate partners. We want to thank you for supporting these efforts. We encourage you to stay in touch by joining our mailing list and following us on Twitter and YouTube. We publish a monthly newsletter. These newsletters offer a current glimpse into the research, events, and notable happenings at each of the UC Davis Energy Research Centers. If you have not yet signed up for our newsletter, you can follow the link on the screen or send me a message with your email address in the question box, and I will get you registered. Today's topic once again is how on-site non-potable water reuse systems can secure California's water future, barriers, solutions, and the business case. And now let's welcome Amanda Rupiper. Amanda, I will make you the presenter.
Thanks, Paul.
There we go.
Perfect. Thank you. Okay, so I'm going to be starting us off talking a little bit about the barriers that these types of systems are facing. Specifically, the challenges they're facing, why these challenges exist, as well as some of the solutions. So first I'll just define what an on-site non-potable water system is. They go by many different names, but I want to make sure we're all on the same page here. Talking a little bit about how they're regulated, because that kind of has affected how these systems have been challenged or the barriers they face. So then I'll transition to what challenges are preventing the growth of these types of systems, identifying not only what these challenges are, but why these challenges exist. Because if we can understand the challenges and why they exist, then we can begin to overcome these challenges by identifying effective and efficient solutions. So on-site non-potable systems often go by other names like decentralized non-potable water systems. But in general, what they are systems that utilize alternate water sources. That could be rainwater, gray water, black water, processed water, foundation drainage. There are numerous. And it takes that alternate water source, either with treatment or without treatment, and uses it for some non-potable application on site or in close proximity. And those non-potable applications could be irrigation, toilet flushing, processing, washing, cooling. But the main idea is that the sources are close to the uses. These alternate water sources are not sent to a centralized facility for treatment and then sent back as recycled water. They are kept on site in a decentralized manner for a non-potable use. Now, depending on what alternate water source that is used, currently, water quality and monitoring regulations are different. So if you are using domestic wastewater or black water, then you are regulated under Title 22 of the California Code of Regulations for water quality and monitoring. And they're very explicit. It outlines what water quality you have to hit depending on your end use. And it also outlines very specific monitoring requirements, often continuous turbidity or daily coliform. However, if you're not using black water, you're using rainwater or gray water, then right now the local authority having jurisdiction gets to decide what water quality and monitoring requirements will apply to you. And that may be different for every local authority having jurisdiction, for every different water source, for different applications. That's how it's currently regulated. However, last year, SB 966 passed, which will require, as of December 2022, the state to come up with standardized water quality regulations for all on-site systems for these different alternate water sources. So each alternate water source and application will have its own risk-based water quality requirement and its own set of monitoring regulations. With the passage of SB 966, not only will these risk-based water quality requirements be set, but it will also require the creation of local non-potable water programs if these sorts of systems will be allowed in a region. So if a local jurisdiction decides they do want to allow these types of systems, they have to establish a program through a local ordinance. This can be your city or county that does this as your local jurisdiction. And this program has to adopt these state-based water quality standards, establish their own design and permitting criteria, establish enforcement procedures, as well as report to the state in an annual report about the systems in their area. Now, what's important to note is if these programs are not established, that on-site systems are blocked from being allowed in that region. So, for example, if an on-site system wants to be installed, but there is no established program, then it cannot do so until an established program is created. Additionally, if a permit is issued under a program and that program is terminated, then those permits are rescinded. So it's important to note that these are required if you want to have a program. If a local jurisdiction decides not to do it, then these types of systems cannot be installed. And that's just helpful for understanding the challenges that I'm going to talk about later. So this is a little bit what they are and how they're regulated. Let's talk about why we would install a system like this. So one of the largest benefits, there are many benefits to these types of systems, but one of the largest benefits is they can reduce your potable water demand. So these are just numbers and time. It can be highly variable depending on your system. But from a residential perspective, a typical reduction in potable water demand you might expect would be about 30%. If you're only doing a laundry system, it might be less. If you're doing it on your bathtubs and showers and flushing all of your toilets and all of your irrigation, that number might be higher. But 30% is a typical number you might see from a residential scale. And if we talk about commercial, that could be as high as 75%. So there's this great opportunity to reduce your potable water demand by installing these types of systems. When you reduce your potable water demand, and by keeping the water on site instead of sending it out to a wastewater treatment facility or having it sent back to you as recycled water, there's also this potential to reduce energy. And this is very situationally dependent, but if we look here at this plot, this is showing the energy intensity of different phases of the water life cycle. And you can see it takes a lot of energy to pump water from the ground, where if you're reducing your potable water demand, you're reducing that groundwater pumping. It takes a lot of energy to pressurize and send water out in a distribution system via booster pump. If you're reducing your potable water demand, you can reduce that as well. And we also save energy by not sending water to a wastewater treatment facility or having it sent back to us as a recycled water. So there's all these opportunities to save energy if the system is designed appropriately. So we know that it has benefits. It can save water, it can save energy, but what we found with one of our research projects is that it was really difficult to get the system permitted and that implementation just wasn't happening. And we wanted to figure out why that was. And so we started by just calling stakeholders in this sector. So we talked to regulators and we also talked to system designers and engineers. We were asking them, were they experiencing challenges preventing the growth of these systems? And what challenges were they experiencing if it was different from the ones that we experienced? And so from these phone calls, we heard things like, in our region, the wastewater utility is very resistant to this and they've been a large lobbying force against it. Or things like, the system was too expensive and so we decided not to do it. Or there weren't the resources to operate a local regulatory program, so they haven't created the program. And these resources might have been knowledge, it might have been financial, it might have been person hours. Or maybe there was a lack of coordination. One of the regions we talked to had a local program at the county level, and the cities were doing their own thing, but they weren't working together. And so we had lots of systems that were falling through the cracks and weren't meeting what would be considered good public health standards. And that was a problem. Or maybe there just wasn't a local regulatory program. So after hearing all these challenges, we asked ourselves the question, is this a challenge that everybody is facing or just this one person we talked to? Is everybody experiencing the absence of a local regulatory program? Is wastewater utility resistance a problem throughout the state? And so we decided to take a more formalized approach and actually have a survey and see, are these widespread problems? Which are the biggest problems? Because if we want to target solutions, we need to know which are the ones that are going to be the most impactful. And so last year in September, we put together a survey and sent it out. We got 114 full responses, and we largely targeted the stakeholders. So we targeted regulators and the system side. For the regulators, we targeted the city. This would be your building inspection departments, the county, which would be environmental health, and the state, which would be regional water quality control boards. We also targeted the system side or the implementation side. So that would be designers of these systems, installers, owners, consultants, operators, and engineers. So people who are actively involved in this sector or would be actively involved if the regulatory program exists. And we got about half and half, regulators and system side. Of the regulators, the majority, 50%, were from the city, about 32% from the county, and 10% from the state. And about 53% of those responding consider themselves very familiar with these types of systems, although about 30% were somewhat to not familiar. So we had a pretty large range in familiarity. And we asked these survey respondents about these challenges. So this next figure is a lot, but I'm going to explain. So from all of those phone calls, talking to people about the challenges they were experiencing, we had come up with a list. A list of 15 challenges. So what you're seeing in this figure here is that list of 15 challenges on the left of the figure. And we asked the survey respondents to take a look at these challenges and bucket them into whether this was being significantly impacting the growth in their perception, which is in red here. In yellow is the percent of respondents that believed this challenge was slightly impacting the growth of these systems. And in green is the percent of respondents who believed that this challenge was not impacting the growth of these systems. And the way this figure is organized, if you were to add the red and the yellow together, that would be the total number of respondents believing this challenge is impacting the growth of these systems. And so it was stacked with the largest number of respondents at the top believing it's having an impact to the smallest number of respondents at the bottom. So the top two challenges, which were tied with about 80% of our respondents believing this was impacting the growth of these systems, was one, the absence of a local regulatory program, and two, the cost of these systems. You can continue to go down, so the third challenge being poor access to training and resources, fourth being limited public education and knowledge, fifth, limited resources to operate it. And you can see a lot of these challenges are related, right? The absence of a local regulatory program is related to the fact that maybe there's not access to training and resources, or maybe there's not resources to operate a program. So these are not necessarily independent challenges, but this is just the order that they were ranked. So we got a sense of what challenges were at the top. We also got a sense of what challenges were at the bottom. So wastewater utility resistance, for example, second from the bottom, a large fraction of respondents believed this was not a problem, but 10% believed it was significantly impacting them. And I think what you can take from that is that it might be a very localized problem. In your region, there might be a wastewater utility that is a big issue, and that doesn't mean you need to address it. But that doesn't mean it's the case everywhere. So I think when we're thinking about solutions, we need to think not only what are most impactful, but which challenges are going to be local and which are going to be global. So we know the ranking of challenges. We wanted to know why these challenges exist. It's hard to overcome a challenge if you don't know what's the cause of it. So we asked our survey respondents not just about their ranking of challenge, but about their beliefs. So we first asked them about their negative beliefs. So negative beliefs could be things like these systems are a health risk. They're difficult to manage. They're not aesthetically pleasing, detrimental to centralized facilities, inefficient, requiring advanced treatment, expensive. And we took those survey respondents and we broke them down into their two categories. In blue are the percentage of regulatory respondents. In yellow is the system side that hold these negative beliefs. And what we found overall is that negative beliefs are more commonly held by the regulatory side. Looking at this plot, there are also p-values on here, which are a result of a chi-square analysis. But all you need to know is if the number is less than 0.05, that means there is a statistically significant difference between our two groups. And you can see that in the first three groups. In the first three categories, these are all statistically significant, meaning whether you identify as a regulator or a system side predicts whether you're going to hold these negative beliefs. So we have a lot of regulators holding the belief that it's difficult to manage, very few from the system side. So when we're looking at solutions or thinking about solutions again here, when we're messaging positive beliefs, we need to know who we should be messaging that towards, and specifically what sort of beliefs we need to overcome. Not a ton of people believe this is a health risk, but 15% on the regulator side do. So maybe that is something we still need to care about. So again, thinking how can we use this to craft solutions? We also asked about positive beliefs. So two of the positive beliefs we asked about are two of the benefits I've already mentioned. Again, there are lots of positive beliefs out there and lots of benefits, but we did ask about potable water demand and the ability to reduce overall energy consumption. And what we found overwhelmingly is that positive beliefs are commonly held, which is very encouraging. And that's especially true from the system side. Again, when we're thinking about solutions, if we want to convince people that this reduces potable water demand, that might not be an effective way to overcome a solution if everybody already believes that to be true, which is great. So not just beliefs, we also asked the survey respondents about their knowledge familiarity, their resource familiarity. There are some fabulous resources that have come out in the past few years really targeting these types of systems and the challenges that they're facing. These are just a handful of resources that we asked in the survey. And if you haven't seen these, you definitely should check them out. They're worth reading. The Onsite, or the National Blue Ribbon Commission for Onsite Non-Potable Water Systems, has been very active in this space and putting out a lot of documents that are definitely worth checking out. But what's neat about these documents is they actually specifically address a lot of the challenges that came up in the survey. For example, in the bottom right corner here, this making the utility case directly addresses the challenge of wastewater utility resistance. So if that's a challenge that you are experiencing, this resource is meant to help you overcome that, which is cool. Also on the left, these two documents on the left, top and bottom, this blueprint for on-site water systems is a step-by-step guide for creating a local program, which the top challenge is the absence of a local program, so I can imagine this would help address that. And then the bottom left is this guidebook for developing and implementing regulations, which includes a model local ordinance as well as model regulations. So really helping local programs get started and creating that local program that will be required for them in 2022. So we have these resources. They're meant to overcome these challenges, but what we found from the survey in a lot of cases is that these resources were not actually reaching their target audience. So I want to keep in mind that the target audience of these resources are the same target audience of our survey, the regulatory side and the system side. And what you're looking at in this figure are those 5 resources I just mentioned across the bottom. And the percentage of respondents that have never heard of this resource are in red. The percent of the respondents that have heard of the resource are in yellow, but maybe not opened them. And the percent that have skimmed or at least opened the resource in blue, and the percent in green that has read them is at the very top. And what you can see is about, for every document, about half of the time, these resources have never even been heard of. It's never come across them. So even though this resource has this great opportunity to overcome this challenge, if it's not getting into the hands of the people who need it, it's not going to be very helpful for overcoming the challenge. So thinking about solutions is how can we get these resources where they need to go? And when they get there, how can we get them opened and read? Breaking it down even further, so taking that same list of resources across the bottom here and breaking it into those 2 categories, blue, the regulatory side, and yellow, the system side, what we're showing here is the percent of respondents that have at least read or skimmed the document. And what we've found is that the system side reads these resources about twice as often as the regulatory side, even though these documents in a lot of cases are targeted at the regulatory side. Like the guidebook for implementing regulations is meant to help regulators get these programs started, but we're finding that they're reading it half as often as the system side. So again, we're getting these documents out, it is getting read, but is it getting read by the right person? That's another question I think that's important to ask. And the last thing I want to talk about here is when we're thinking about solutions, if the documents aren't getting where they need to go, we need to know where do these groups get their information. So if we do want to get this information to them, how do we do that? So we asked our survey respondents to tell us how they get information about on-site non-potable water systems. And we're showing that here. Do they get it from conferences, webinars like this, from an email listserv? Maybe they don't get any information at all, from their employer, websites, or other. And again, we're seeing the regulatory side in blue and the system side in yellow. And what we're finding is that the system side utilizes more sources than the regulatory side, in all cases for the most part. And a lot of them get their information from conferences, which is wonderful because I think a lot of these challenges and resources are presented at conferences. So if you're attending a conference and you talk about it, it's a great way to disseminate information. There is a good chunk that gets them from webinars like today, which is awesome. But 30% of regulators don't get any information at all. So if the regulators aren't getting the information as is currently happening, and they're not going to conferences and they're not going to webinars, then how are they going to get this? So again, thinking about solutions, we need to be thinking outside the box. How do we target that 30% that isn't going to a conference and is not going to hear about it when we talk about it? Who isn't listening to this webinar and isn't going to hear about these resources today? And so that's kind of transitioning me a little bit into these solutions. So keeping in mind everything that we know the challenges are existing and needing to help support these local regulators get these programs out there. And one way to do that is to create regulator-specific trainings. This could be an online or in-person training that goes straight to the regulator in a system that they are currently getting their information. So regulators do have to get continuing education units, CEUs. And so if we can create an on-site non-potable water system training that can address or fit right in with this existing training structure, that means the information is coming straight to them in a way they can digest. They do not have to open a document. It's coming straight to them, and they already have to do it. So that targets that group. That's one possible solution. Another possible solution is creating an on-site non-potable water system dedicated organization, or maybe it could be an existing organization that takes on some of these roles. It could be a place where you could go to ask and answer questions. If you're in a locality that doesn't have a local program, you might not know where to go to answer your questions or to ask your questions. And the county next to you might be doing something entirely different, so they might not be appropriate. So having a centralized location where you could go to ask your questions, I think would really help us overcome some of this confusing permitting process challenges. It could also be a place where knowledge is shared. So right now, each local jurisdiction is working independently. They're creating this program, and then any information or knowledge they gain from doing that stays with them, and the county over has to start from scratch. And I think if we could share a lot of that resources in one central location, we're not reinventing the wheel every time, which is just making it more efficient. Likewise, having all of our resources housed in the same location means you're more likely to find them. So if you find one resource, you find all of the resources, instead of having to search to find these things in different locations. And as time progresses, this could be an organization that maybe eventually does certification. It could be doing operator certification or technology certification as we move down the road to really help inspire confidence in the regulators permitting this, and then also from the system side, knowing what's required of them. And then this last solution, I think, is one that's already being done, and I think that's wonderful, and it just needs to continue. So it's these highlighting positive examples. So once these systems are in place, it's really important that we talk about them. Research was done a couple years ago in California, looking at people's perceptions of water reuse, and they had a couple different groups, and they talked to one group just telling them about the systems and educating them about safety and just basically educating them about reuse in general. And it did very little to increase their public opinion. But to the other group, they didn't talk about educating them in reuse. They just talked to them about systems that already exist in their neighborhood, in their backyard. And what that did is it really changed their perception because it normalized it for them. These systems are common. We don't need to think that this is outside the box. We can just accept it. And so I think talking about our examples makes it more normal and makes other people feel like confident and like they could do this too. It's not some extreme thing that's happening. So that's kind of the last one. There are other solutions, and if you are interested in reading more about this, this was published recently in the Journal of Resources, Conservation, and Recycling. So if you want to see more of our figures and more of our findings from the survey, you can find that there. But that is all I'm going to share right now. I'm actually going to pass it off to Amelia, who's going to continue on talking about the business case.
Thanks so much, Amanda. And let me get my screen going here. Okay, great. So Amanda gave a great overview of some of the work that has gone into understanding barriers and looking at both the system side and the regulatory side. I work at Sherwood Design Engineers, and most of the time we are working on the private side, so working with developers and universities and other folks looking to put in new buildings that often require new infrastructure. So I'll be speaking from that perspective primarily today, but I do want to highlight again this how we identify co-benefits to both the utility side as well as what I'll just continue to call the developer side. So business and highlighting the business case from both of those angles. Great. So Amanda did a great job of explaining, sort of what these systems are, but I will do a little bit of repetition here to set up some of the agenda I'll go over today. So what is the opportunity? I think diving into understanding what the opportunities are and how they are identified is an important part of the process for any project. And then project delivery considerations. I think that's a particularly important topic when we understand the different way in which projects at a smaller scale are delivered versus large utility projects, which will lead into the critical nature of project timing, I'll go over a business case study and the approach to evaluating those studies, and where I think we're headed next. And I do like to use this quote from the U.S. Water Alliance. This is one of the resources that Amanda highlighted, which is making the utility case for on-site non-potable water systems, which is that there are lots of benefits for these systems, but I think it's really up to each project to identify them. So again, encourage folks on the call to reach out to those resources and share those resources with the folks they work with in the industry. Got a little bit of a lag here on my screen, so I apologize. Great. So as we go through the presentation, I just want you to consider that on-site non-potable water systems can be a transformative opportunity for our water and wastewater infrastructure. But as Amanda pointed out, there are barriers and other risks that the benefits might not be realized. So we really want to understand what all the driving forces are behind these projects and understand that a one-size-fits-all approach will not work. And then I'll highlight that there are some changes to the market for these systems that are driving some of the developers away from a business as usual thinking in terms of how we connect to infrastructure. So just to reiterate some of the definitions, what I'll be talking about today are these satellite water reuse systems from black water or wastewater, full wastewater collection all the way through the different alternate water sources Amanda covered. But I wanted to highlight that these systems are connected, and I like using this graphic to demonstrate that. So these highlight that there are many ways in which a system can be grid connected, and that includes residential gray water. It includes mining from or what's called sewer scalping from an existing sanitary sewer. It may include a community that's upstream that does an interception type system, or an in-building system, a lot of which we're seeing now in San Francisco with their non-potable ordinance. And what I'll highlight is that each of these systems is fit for purpose. So we're using opportunistically water sources that are available on site, and finding a end use for that water source that is fit to and treating it to that water quality level for that end use. So really quickly highlighting what some of those opportunities might be in a residential building. There's much more gray water available, so understanding that it might be an opportunity to separate that gray water and treat it minimally as required by regulations for subsurface irrigation. Commercial buildings where we may be introducing a lot of impervious area where rainwater and stormwater can be collected. That's fairly high quality water, especially the rainwater coming from roofs, and could be used, say, for cooling demands. On a site scale, when you start to look at multiple buildings or a larger scale, a full black water or wastewater treatment system for the sort of big three on-site water reuse purposes, irrigation, toilet flush, and cooling might be considered. Or there may be a scalping system at a district level, which really increases the scale of the system for something like a golf course or an agricultural end use. So as we start to understand what these opportunities are, I wanted to highlight that location and scale are pivotal to understanding the benefits and quantifying the benefits of a given opportunity. So research conducted by Ola Kavada and folks at UC Berkeley found that water infrastructure, we know that water infrastructure is spatially sensitive, but they did find, I think it's at a high level important to emphasize that for a centralized system, the majority, just over half, about 60% of the energy use is in distribution, whereas an on-site system, that tends to be much lower at 15%. So if you're located further away from a centralized treatment plant and potentially there's some topography involved and you can scale at the right size of their system capacity, there's really a great opportunity for reducing the energy intensity of water reuse through decentralization. So I'll sort of posit this hypothesis, which is that a region that optimizes the system to take advantage of ideal scale will reap the benefits of those systems. So we're looking mostly at resilience as a topic of discussion, cost, and also how that cost is distributed publicly and privately, greenhouse gas emissions associated with energy use, primarily, and then water security. So understanding there's this becomes another water source available. So to kind of look at that in an abstract way, especially when we talk about resilience, the introduction of satellite on-site reuse systems gives the network, the wastewater treatment network, collection network, treatment network, as well as the water supply network, a bit of redundancy. But we know that, as shown in the figure on the far left, that fully redundant networks are very expensive. We can't have full redundancy all the time. That's we make those decisions as design engineers constantly. What is the appropriate level of redundancy? And cost is a big driver. But if we have no redundancy, as shown in figure B, there are a lot of weaknesses in that system. If one of those nodes breaks, the system is shut down for the nodes that become disconnected. So we know zero redundancy is undesirable. It's not resilient. So how do we shift more towards what you see in figure C, which is an appropriate level of redundancy, having a hybrid of centralized and decentralized networks that can help to optimize our opportunities for water and resource recovery. So I don't expect you to read all the words on this slide, but I just wanted to highlight that we've been looking for over a decade via the published literature, and I've only gone back so far as 2007 here, looking at some of the UC Davis research, and I'm sure this is not comprehensive, but I just want to highlight the progression of this research over time and the work the academic field is doing in deconstructing the benefits and barriers, not least of which is the research Amanda just covered. So understanding that there has been a lot of work to uncover what the benefits are and identify those barriers. And in order to realize the benefits and understand the right scale at which to deploy some of these solutions, we really need to start implementing. So I mentioned that I'll be speaking mostly from this sort of more developer perspective, and that's to say that there is a sort of cultural gap that exists between the utility world and the development world, and I think that talking about some of the language from the development perspective helps us to bridge those gaps. So just quickly to give an overview, there are many different ways that projects are delivered and ways in which owners become engaged in those projects. So in a conventional design bid build, shown in the top left of this pie chart here, there is a complete owner risk. The contractor does not have a share in that risk. But when you go to design build, the general contractor will take on some of the risk, especially with respect to cost and schedule for delivering a project. And then more shared risk comes with design build, own and maintain. And then additional risk with financing. So what we are seeing, especially in the larger scale systems, that there are opportunities for those that are specialized in building on-site reuse systems can actually also finance these systems and become a sort of one-stop shop, if you will, for delivering on-site reuse systems. So there's some education needed on the developer side for understanding which of these models to choose, and then also on the utility side, understanding who then to look to for responsibility on these projects. While the regulatory framework is simplifying, I don't know if everybody would agree with the simplification qualification, but I do think it is, and I've just shown that, for example, for stormwater, as Amanda pointed out, would be regulated mostly through local code today, whereas wastewater would be regulated through state code. That will change in the future. So we do think there are, that barrier is reducing. But what I believe is not yet really fully realized is understanding that there are novel or new to the field of water and wastewater management funding and governance frameworks, and I believe they're underexplored. So what you see here is a structure that was set up for the Lloyd Eco District in Portland, where they do have a on-site non-potable water system, which is a full wastewater treatment and reuse system. And what they've done here is to identify all of the stakeholders in that system and to make sure that its roles and responsibilities are very clear, and the organization of that eco district, as it's called, is well understood. And what you'll find in another one of the resources Amanda mentioned, which is the final report from the RiskBased Framework study, is a chapter on responsible management entities. So identifying who the responsible management entity will be and getting that confidence on both the developer and the regulatory side that this is a project that will be carried through and there's somebody to be responsible for all stages of that project. So I think that this does represent a bit of an innovation deficit. I would say that on the one hand, and that deficit is recognized in the literature, but we do know in the water industry that innovation is achieved by doing, through doing. So pilot studies and those, there is very innovative work going on at the utility side, especially with respect to pilot studies and topics like nutrient recovery, et cetera. But we do need to continue to push our industry to innovate, especially in this organizational field I mentioned. And I wanted to point out the critical nature of timing. So I mentioned, innovation is achieved through doing in this industry. And, it may be through doing pilot studies to determine, how to improve upon a treatment plan. But oftentimes on a centralized scale, those the benefit of those studies, the benefit of that innovation is realized on a much longer time scale. And we see some of that work, taking place now as treatment plants are being rebuilt as they reach end of life. But I would also point out that small scale systems can be constructed on a shorter timeline, and that allows for that rapid innovation and iteration on those systems. And we also understand that because timing is so critical, an expense deferred today has value today, right? Whereas a project that may take longer to implement, we might not realize that value until much later. And so, time is money, I guess you could say, and there may be opportunities to defer some upgrades, not to neglect them, but just to avoid them. For example, through avoided cost of expanding a sewer or avoided cost of upsizing a sewer size because you are treating that wastewater on site. There may be operational savings at the centralized plant for volume that's diverted, or avoided cost of expanding the recycled water network by allowing that recycling to happen outside of that network. So optimizing centralized and decentralized infrastructure can work together to benefit the entire system. It's not an either or. But I'll highlight for the developer side, a really important part of realizing these benefits is to demystify the entitlements process and create predictable outcomes to meet permitting schedules. So again, time is a very critical element, and somebody who may be interested in implementing an on-site reuse system would be deterred by uncertainty in timeline or viability of implementing a system. And then I would argue on the right-hand side that utilities stand to benefit greatly. For example, and just the items I mentioned above, also bolstering regional infrastructure. So how are we investing in resilience? Is this an opportunity to invest in resilience where that cost can really be deferred to the private side? So looking at the business case studies, oftentimes from the development perspective, they're wondering, how will I pay for this investment? And I'm sure on both the utility side as well. One of the first things to review in a business case assessment is what is the true business as usual cost? And that often does involve some investments up front. Whether it's extending a sanitary sewer or upsizing a sanitary sewer, we want to make sure we're comparing the cost. As Amanda pointed out, cost was seen as a major barrier for implementing on-site non-potable water systems. So we want to make sure we're not just looking at the cost of implementing that system, but also the cost of not, and how do those two compare and taking the delta. And then other life cycle costs. So what would it take to operate the system over time is a very critical part of the consideration. And any opportunities to offset first costs. There are many cities across the U.S. and nationally, there are systems that are getting funded through nonprofits or through incentive programs. So identifying those. And then making sure that any of the less tangible benefits are articulated, such as a resilience benefit that might serve a whole community. And then understanding that, water and sewer and stormwater rates, may be avoided as a result. So I just wanted to highlight very quickly an example from Atlanta, where we looked at a couple of alternatives for an on-site non-potable water system, one of which included the dual plumbing and one of which did not. And this is in understanding how that analysis occurs as the combined municipal water and sewer rates increase, and as the scale of the system increases, the chance that that's going to be an economically viable system increases as well. So this is a general framework that would need to be applied for your specific location, but it's a good general rule of thumb. And what we found in the Atlanta study was that in either case, there was a very short payback, even including dual plumbing a building, which can be an added cost to a project. So I won't go into the details here, but just to say that, you know, it's important to do these studies and to understand that from the development perspective, these studies are being done. And so how do we balance that against the need for also investment in the public utility networks as well, and how can they work together? So what's next for the industry? I think, again, going back to the business case and looking at water and sewer rates, we did a study just researching what's publicly available in terms of a local, and this was in the Bay Area, so looking at Santa Clara Valley Water District and SFPUC projections for just the wholesale water rate. So it's just an indicator, it's not a comprehensive thing, but understanding that water and sewer rates are going up, right? And how might that impact business decisions that owners are making as they invest in development. You know, we have a somewhat unique case in terms of the amount of development in California, but this is the kind of lens that we want to put onto understanding what types of projects we want to build moving forward. So doing this kind of rate forecasting actually is also a bit of a risk analysis. So an owner might say, do I believe that we would follow the higher rate projection or the lower rate projection? And I'm going to make a decision based on that. And I would say that stressors direct risk tolerance. So climate change, increasing urbanization, the decay or the aging of existing infrastructure, and restrictions on regulations. All of these factors are stressors on our system and may change the types of projects that we build in response compared to the past. So in conclusion, some of the themes that I touched on today are that, you know, these non-potable water systems can be transformative opportunities, but there is a need to engage in engineering assessments early on and create informed decision-making on the type of system to be implemented. But if we understand all the driving forces, including regulation and structuring of the sort of organization around how a system will be built and operated successfully over time, timing is critical. So if we don't understand that we want to move these systems forward so we can reap those benefits soon, then we don't realize that some of those benefits. And then changes to the market demand. So thinking about resilience, thinking about increasing costs of water and sewer rates is going to drive the development side away from business as usual thinking. So how do we project sort of project appropriate business case framework? And I want to add also engage on the regulator and utility side to come up with solutions that are mutually beneficial. So with that, I will pass it back to Paul. Thank you, everybody, for the time.
Great. Thank you, Amelia. So I'm going to go ahead and open it up to questions. I have a couple questions already. What impact do you expect the passage of SB 966 will have on the perceived challenges after the provisions are in place in 2023?
I can take that one.
Okay.
So with SB 966 passing, the two main things are that we're going to have these standardized water quality requirements, which a couple of our challenges just get knocked out right there. So that's great. We no longer will have the challenge of the lack of monitoring reporting or a lack of water quality. But the other thing with SB 966 is it's going to require these local programs. And right now we know that these local programs in a lot of cases don't exist, and they won't just suddenly exist in 2022. And there's not any resources to do that. So I think it might actually exacerbate some of these challenges where the programs need to be in existence in order for these systems to be there. And systems that already exist without a program are now in this like gray zone. Can they still exist? And we don't have the programs there. So I think that's going to be the big challenge. The other thing is SB 966 requires that these local programs, before they're put into place, have to actually talk to their wastewater and water utilities and let them demonstrate whether there will be a significant impact to them. So if these wastewater utilities say, no, we don't want this in the area because it's going to affect us in this way, then these local programs have to actually address that issue before this can move forward. So we actually might see this delay happen where these utilities get more power to actually push this off into the future. So I think there will be progress, but I think it's going to be this delay. It's not going to all of a sudden be better by 2022. We're going to see this lag where these programs are not getting existing, and then systems can't be informed to support the program. And I think that's something that's going to continue to be the case even after that bill passes or gets in place.
Great.
I don't know. Amelia, do you have any thoughts on that or no?
We'll just move on. All right.
All right.
Oh, sorry about that. I was muted, but I think Amanda covered it.
Great. So we have a first question here from Keira Stoll. Is the University of California exempt from local or state ordinances?
I'm not sure.
I can address that.
Yeah, go ahead.
Sure. So my understanding is, and this is, I'm not the expert on this, but that UC campuses do sort of have they regulate it more at the state level, and they don't have the same. They don't have to respond necessarily to what a local authority may require. They sort of govern. I don't want to say govern themselves, but there is a bit more flexibility in my experience with that. That said, for example, if you're looking at stormwater reuse, there's still a MPDS stormwater permit that must be met as determined by the regional board. So they still work with the regional board on environmental water quality issues. But as far as water reuse goes, they have some flexibility in how they set the water quality standards. So I think that's an interesting question as we move into the implementation of SB 966 is, what would a local program look like for UC campuses? Perhaps it's a UC system-wide program or something like this.
Great. Another question here from Andrew Faulkner. I've heard of some projects obtaining water rights by offsetting potable water use with reclaimed water. Have you heard of this? And when is it applicable?
I can take this. So I'm not a water lawyer, so I'm not sure in terms of the rights, but I think there is what I've seen as a pretty pervasive trend in the industry is to sort of overestimate the amount of water a project will use, because a lot of the data that we use for our urban water management programs is based on potentially somewhat dated unit water demands or demand factors for water. So, for example, looking at factors prior to the implementation of low flush toilets. So that is a legal framework in terms of understanding when a project gets entitled, there is a water supply assessment that must be conducted. So if that water supply assessment is using much higher water use numbers, that could negatively impact the project's ability to get approvals, although that's rare, but it could happen. So in a sense, if your local water provider is willing to work with you to recognize that using recycled water to offset, for example, toilet flush in a dual pump building would give you, pretty substantial credits towards the amount of potable water you would have to use. So that's typically a conversation that needs to happen with your local water utility, but certainly it is a opportunity, let's say, in the industry for modernizing the way we look at assessing our available water supply.
Great. Shirley Rosielela, I apologize if I have butchered your name. What was the geographic makeup of the survey?
Yeah, we actually got a really good spread. So 67% of the counties were represented in California. So it was pretty good spread. However, we did have most of our respondents from 4 counties. So that would be Santa Clara, Sonoma, San Francisco, and Los Angeles. But we had at least one person from most of the counties in California.
Great. I'll go ahead and leave a few more minutes for people to put in some questions if they'd like. Keira has another question, or maybe not a question. Let me read it. For an on-site treatment facility of non-potable water intended to be used for landscape and possibly for thermal systems, how critical is the location of a facility on a campus, for example? If you use for landscape, do you need to also develop a separate water system?
Using a non-potable water source, like an alternate water source? Sorry, I didn't catch the beginning.
Sure. It's yes, non-potable for an on-site treatment facility of non-potable water intended to be used for landscaping, possibly for thermal systems.
Okay. I think if it falls within some local jurisdiction, then it has to follow those requirements. I know here in Davis, if Davis were to pass a local ordinance to create a program, the city of Davis, then that's what we would follow for all of our projects as well. So it's up to the local jurisdiction. So if you fall within that local jurisdiction, you have to meet their requirements currently until the State Water Board comes up with these standardized requirements.
Was the question also like where might one locate a treatment system within a given project? I understood that correctly.
It was more, how critical is the location of a facility?
Okay. Yeah. I mean, I would say typically that there's a lot of variables that depend on what type of uses you have across the facility. But one thing I would like to point out that it is, Amanda mentioned positive examples of systems is really important. And so one thing we try to always think about is making our systems visible. Or, for example, the SFPUC headquarters in San Francisco has a very visible water reuse system. And so as far as locating these systems on projects, I would encourage you to make them visible as is tolerated by the project team and development team. But for landscape reuse, there's just a separate distribution system for the treated water that would go out, but that's a very typical use. So no special considerations there.
Great. Mark, I just wanted to answer Mark's question. Initial one was, will the PowerPoints be available for download? And I believe they will be for everyone, at least on this webinar. The next question comes from Andrew Faulkner. In your experience, is there sufficient demand in the Bay Area for excess reclaimed water? For example, if I can't consume all my own reclaimed water on site, can I sell it elsewhere?
That's a great question, and that would probably encompass what we would call a district system. So, where the recycled water that you're treating at your project would leave your project site and go to somebody else. And that's really where I think we don't have a lot of precedent for how we organize these systems, really from a financial sort of accountability, reporting, legal framework standpoint. So yes, San Francisco has blazed the trail in trying to set up district scale programs. The sale of that water will very much depend on how you organize that structure, that responsible management entity. But that can also be a sticking point with your local water purveyor. So you would need to work through those local concerns together with your local water regulator. But I would say it's also a ripe field for legal work, for folks to develop those legal frameworks. But in the Lloyd Eco District, which I mentioned in my presentation, there is a single entity who developed the system, I believe, funded the capital, and actually provides all of the water out to the mixed use development. and also invoices for that water. So yes, they are charging across multiple properties for that recycled water.
Great. Mark Martinez asks, were there any energy savings or demand reduction benefits identified in this or other parallel research for water reuse strategies?
Yeah, UC Davis is currently working on a project with a winery, specifically tracking water and energy use. And we haven't finished our studies, but we are seeing a reduction in both water and energy. And I think it really comes down to the site specific, locating them in the appropriate locations. You know, you save pumping out to a centralized facility if you're located far away from a centralized facility. If you're located right next to it, then you might not see those energy savings. So I think you're going to see these energy savings in really appropriately placed systems. And I think Amelia talked a little bit about that, really recognizing where this is appropriate and then to maximize these benefits.
Okay, great. Any other questions? Great, they're popping up here. Cheryl, other than City County of San Francisco, are you aware of any other established local agency programs?
Yeah, I think LA is one of the other counties that I think are pretty prominent in this. They are different, obviously, because their city and county are not the same. So the county has a local program, and then the city obviously has their individual building inspection departments. I think a lot of other counties are in the process of doing this, but it is a difficult thing. So those are the two that I know for sure have programs, and I think a lot of other ones are in works. To the best of my knowledge, I'm sure there are some other ones out there.
Yeah, I was just going to add on. So outside of the state of California, the city of Austin is actively developing a One Water program that incorporates on-site reuse modeled after the San Francisco program. And in New York City, they have an incentive program for both site and district scale systems. You can get up to, I think it's like $500,000 for a large scale district scale system. So mostly the city of New York is motivated by preventing impacts to their centralized sewer collection system. So, and I know up in the Pacific Northwest, they've grappled with some of these regulations over the years. And so as far as creating local programs, I really think from a regulatory and water quality perspective, nationally, we'll see the risk-based framework be adopted.
Great. Any other questions? Nope. Okay. Well, thank you all for participating. And, here's all of our contact information. After the webinar, a short survey will appear. We would greatly appreciate you to take a minute to complete it. And we will be sending out the copies of these presentations shortly. And thanks again for joining us today, and we'll see you next time.